Thermocouple is a transducer that converts thermal energy into electrical energy and is constructed by joining two wires made from dissimilar metals to form a junction. Voltage is produced when the temperature at the junction is changed. This is the simple diagram of a thermocouple having two dissimilar metals and it is connected with a measuring meter. The concept of thermocouple is based on the Seebeck effect, which states that if dissimilar metals are joined at a point, they will generate a small measurable voltage when the temperature of the point of connection is changed. The amount of voltage depends on the amount of temperature change and the characteristics of the metals. Thermocouple working on three main effects. They are Seebeck effect, Peltier effect, Thomson effect. Seebeck effect. The Seebeck effect happens when two different unlike metals are joined together at two junctions. An electromotive force is generated at the two junctions, which is different for different types of metals. Peltier effect. Conductors made up of different materials have different free carrier densities. When two dissimilar conductors are joined, electrons will diffuse across the junction from one conductor with higher electron density. Conductor which losing electrons acquire a positive voltage with respect to the other conductor. Thomson effect. The Thomson effect, if the temperature of one end of an conductor is raised above the other end, excess electrons from the hot end will diffuse to the cold end. This results an induced voltage that makes the hot end positive with respect to the cold end. The working circuit of thermocouple is shown in image where A and B are two dissimilar wires that are joined to form a junction, hot junction, and other junction is cold junction. When two wires of thermocouples are joined to form a junction, one of them is referred as a hot or measuring junction used to measure the unknown temperature. The second junction is attached to the known temperature and is the reference junction or cold junction. A thermocouple measures an unknown temperature and compares it to a known temperature. Electrons carry heat and electricity. If piece of copper wire is heated at one end, the electrons will move along the wire to the cooler end and create a temperature gradient along the wire. The heat has been changed into energy. A millivolt signal is generated when the junctions are different at different temperatures. For a thermocouple measures, it has to measure a cold junction compensation using an ice or water bath to set the reference temperature. The two ends of thermocouple are kept at the same temperature while the hot junction is compared to the cold junction. Thermocouple wire is thicker, it can able to measure higher temperatures but at lower response time. If the junction of a thermocouple is at same temperature, an equal and opposite EMF will be generated at the junctions and the current flows will be zero. If the junction have different temperatures, the EMF will be non-zero and the current flows to be flowing through the circuit, much like the heat flowing through the copper wire. The flow of EMF through the circuit depends on the metals and the temperature of the junction is measured by a meter. Thermocouple types. Types C, E, T, N, J and K are common thermocouples or have base metals of iron, copper, nickel, platinum, rhodium, chromium. Type C thermocouples are made of tungsten and rhodium. They are used in applications that produce high temperatures up to 4200 degree Fahrenheit or 2315 degrees Celsius. Type E thermocouples have chromium and constantan, and the temperature range is over minus 330 degrees Celsius to 1600 degrees Celsius. Type J thermocouples have iron and constantan. Their temperature range is 32 degree Fahrenheit to 100 degree Fahrenheit. Type N thermocouples are made from nicrosyl and nisyl. It is the alloys of nicrosyl is nickel chromium alloy. Nisyl is nickel, silicon and magnesium. These type of thermocouples have temperature range 32 degree Fahrenheit to 2300 Fahrenheit degrees. Type T thermocouples are designed from copper and constantan, and the temperature range is minus 330 Fahrenheit to 700 degree Fahrenheit. Thank you.